Hi, good afternoon to all. Am I audible? Please give me a feedback.
Good afternoon, sir.
Yeah, perfectly audible now.
Yes, sir.
Yeah. Okay. So, any problems from yesterday's class? We will spare 2 minutes of time for others to join also. So, are you being able to hear some sort of background music? Yeah. Are you able to hear some background music? Is it okay, or is the volume very
Yes, sir.
low or high?
Not so high, sir.
Now is it okay? Feels comfortable?
Yes, sir.
Yeah, at 30%. Okay, so let's wait. So let's do a bit of revision from the previous class. So it is now advantages of electrical drives. So what are the advantages of electrical drives? It has, we have already discussed it out. So it has flexible control characteristics. It has wide range of speed, torque and power. It is high efficiency. It is low noise. It is of low maintenance requirements, cleaner operation, there is no exhausts. The electrical energy is easily transported, for which it is better. So, just a second, I'm receiving an important call. Just a second. Yeah, sorry for the interruption. Okay, so it is adaptable to most operating conditions. That means you can operate it underwater also, in harsh conditions also, like in marine conditions, like in mines, under the mines conditions also. And most of all, it is available in all the four quadrants of operation of the torque. And this is the torque and this is the speed. If you go for this kind of operation, you will have all the four quadrants of operation available in an electric drive, right? So these were the advantages. Now, coming to the historical background of electric drives. Okay, why so low number of people is present in this group? We have 60 members and we have only 15 members coming online. Please tell them that if this continues, no one will get to give their exams. This time the attendance is being considered strictly, as the systems has become already well established. Right. So please tell your friends to join soon. Write it in your groups. Yeah, who is taking the responsibility of doing this? Puran, can
Same
you?
time. Same
Yeah,
time.
yeah, we will do it. Okay, so what is the historical background of electrical drives? So the historical background is something, it is a very crude way of giving power was available in the earlier times, where the performance of the power being given is was not considered so much good. Right? It was just being given in some way or the other. Right? Means so earlier there were line shaft drives. This one, line shaft drives. So what is this? A single motor was earlier used to drive equipment through a common line shaft or belt. So it is inflexible and inefficient, as you cannot change the speed of each load alone, right? So if you can see in the photo here, if you see this, there is only one motor, and from the one motor, say for this example, this is a motor, right side. So this is a motor, one motor is rotating, and it is being connected to several other loads. So this is load 1, load 2, load 3 through some kind of connecting mechanisms like load pulley and all these things, gears, pinions, and all these things. So problem with this happened because you cannot control the speed of each load individually, and it is quite inefficient because the means of transfer of power from the motor to the load is through another transmission system, right? So it was not so much efficient. Then came this single motor single load drive. So for each load you will have only one motor. So that is what came the system like. For each load you will have a separated single motor. So this was the fashion then. For a single load you will have a single motor, right? So single motor is dedicated to each load. Applications include hard disk drives, washers, dryers, fans. You know, dryers are there in the washing machines. You can see that it has a single motor dedicated to for drying on only, like the spinner. And then washers are there. Hard disk drives, as you can see in this picture, it is one motor is there for only one load, right? So each motor is controlling each load. Now what is the era? Now the era is of multi-motor drives, right? So several motors are used to
Sir,
drive a single mechanical load. Yes,
so can you show me the previous slide, sir?
yes. Any questions on that?
Yes, sir.
Sir,
Tell
Sir,
me.
I joined late. Can you explain that single motor, single load drive?
Deep. From the next class, I want you in time, right? Don't join
Okay,
late. We will lag in our syllabus now. Right. So what is single motor drives? Say there is a motor, single motor, right? And that big motor will drive all the other loads through a connecting mechanism, right? Is it now okay? This single motor will run, and it will drive all the other loads. Yeah, this is load one. So it can be something else. This can be something else. This can be something else, right? But what the problem happened with this? So what is the advantage with this? That you need only one motor for all the loads, right?
yes, sir.
But what is the problem? That if the speed of the motor is varying, then the speed of all the loads will vary.
Yes, sir.
Another thing is that if one day this motor is not working, then all the loads will go off.
Yes, sir.
So these are the, and the transmission efficiency is less because see, the motor is not directly running the loads. It is running through a transmission mechanism. So where is the transmission mechanism? These are the transmission mechanisms, right? These are the transmission. This is the load pulley arrangement where the transmission is happening, right? So that is why this problem was there. However, then the era of single motor, single load drive system came in. For a single load, a single motor was being dedicated, right? So you can see this in your hard disk. See, for this one hard disk, only one motor is there. Now, say for any other, like your washing machine will have one motor for the entire washing machine, right? Then dryers, fans. So single load, single motor application. Earlier it was multiple load, single motor application, right?
So,
And
sir,
then, yes,
by using drive, we can
by
control
using,
nothing. Drive, sir.
yes, by
So,
using drive.
sir,
by using, we can
sir,
control the single motor multiple loads, no, sir.
By what? See, whatever drive you employ, can you change the speed of each and every load? Say load one is at 200 rpm, load two is at also 200 rpm. So if that motor speed is changing, can you keep the load one and load two speed constant? Obviously not.
sir,
Yes. So
sir,
are you
if the
clear
values
with
of
that
drive
thing?
is
Puran next something. Are you clear
Sir?
with the answer? Just
No,
let me
sir.
complete it.
Sir,
Yes.
sir, what is the speed of motor, sir?
Say it is running at 200 rpm. Say the motor is running at 1200 rpm,
Okay, sir.
right? And say by load pulley arrangement, you have made this as 200 rpm. This one is also at 200 rpm. Now suddenly the motor speed changes from 1200 to say 1500 rpm. So can you keep it constant? 200 rpm? No. It will also
No, sir.
increase or decrease,
Yes, sir.
right? And then
Yes,
it
sir.
is also inflexible and inefficient. Inefficient why? Because you are not directly rotating the load through the motor. You are employing a transmission mechanism here, load pulley arrangement, right? So this will have might be having a transmission efficiency of 90%, right? So more the losses are there.
Yes, sir.
Is it okay now?
Yes, sir.
Yes. Uh, any other questions someone was trying to ask? I think Abhijit was trying to ask. Yeah, speak up, Abhijit. Yeah, we are waiting for
The
your
lines of
question.
drive is very delicate.
Can you repeat your
Sir,
question? Can you
sir, is
repeat
the
your
lines of
question?
drive must be very delicate.
Is the line sub-drive?
Sir, is the lines of drive is delicate? No, sir, lines of drives. First one is very
Uh,
delicate, I think,
I
because it is connected to through common soft.
this one. Yes, yes, yes.
Yes, sir.
Because if one day you go to the factory and see your motor is not working, all the other loads will stop working, right? All the other loads will stop working, no?
Hmm.
So if the motor fails, then the whole of the factory will sit down, right? No other work can happen. So that is also a big problem as far as the advantage, and it's also a problem. Then the single motor, single load drive system. What is this? A single motor, single load drive system will employ a single motor dedicated for that single load, right? As you can see a washing machine. Have you seen the inside of a washing machine? It has a motor, no? An induction motor. So for each and every application, it will have a single motor. Right. So that
Sir,
was the area then. Yes.
sir, but why do we need to keep the load 1, load 2, load 3 speed constant? I don't understand. Like load 1 is separate, load 2 is separate, load 3 is separate.
Yeah.
If they operate at different speed, it should not be any problem.
See, I don't know. It will depend upon the application. Right. Some applications may need that the load one motor speed should be constant at 200 rpm, and they should be constant at 250 rpm. They might require, who knows? You don't know, because I am not pointing out to a specific application area. I'm I'm telling that these might be the requirements of the user. Say just for example, right? So I can show you one application. Say this is a roller and this is also a roller, right? So say what is it rolling? It is rolling paper, right? It is rolling paper onto this bundle. So this is bundle one and this is bundle two. So this is has all the paper here, and the paper is going like this, right? Now tell me, if it is rotating at 100 rpm, if it is rotating at 100 rpm, then things are quite okay, right? Things are quite okay.
Yes, sir.
Now say if this side is rotating at 98 rpm and this side is still rotating at 100 rpm, what will happen?
Paper will break.
Sir, that roll 1 will come first and roll 2 will.
Now what will happen to the paper? This is paper rolls, right? So this is paper being rolled onto a drum. This is like, say, like a drum. This is like a drum which is to be sold to the market, right? So tell me what will happen to the paper.
Paper might get disturbed, or that rolling process will get.
This is at 100 RPM. So this is pulling faster, right?
Yes,
And
sir.
this is supplying slower by 2 RPM,
Yes, sir.
right? So what will happen? There will be stress on the paper, and after
Yes, sir.
some time there will be a break in the paper. So the paper will tear out, right?
Yes, sir.
So it is very delicate, no?
Yes, sir.
Now say the reverse is happening. This is supplying at 100 RPM and this is rolling at 98 RPM. Tell me what will happen?
Again, it will tear, sir.
No, it won't tear. It is supplying faster and it is rolling slower, taking in slower at a slower speed. So what will happen? The paper will be supplied more by 2 RPM here.
Yes, sir.
So what will happen? It will keep on like an extra paper drags. It will keep on assembling at the bottom point. After some time, you will see a pile of papers floating on the ground, just like that. Because by 2 RPM, more extra paper has been supplied, and lesser of the paper has been wrapped. Are you getting the point?
Yes, sir.
Yeah, so it is very important that the two drums rotate at the same RPM. If this is at 100, this side should also be at 100, right? There should be no disturbances with this, right? So these are critical applications. So there may be other applications also dependent upon that industry, which might require you to change the load, the speed of the loads from, say, their specified limits. It might come. Yeah, it is very much probable. This will definitely come in an industrial automation things. So you cannot do these things with this type of system. So people went for single motor, single load drive systems, right? So what was the advantage? The advantage was super control. That the control was very fine, right? Like washing machines, dryers, fans, all these. Then came the multi-motor drives. So what about the multi-motor drives? This is something the reverse of the first case. In the first case, what was the thing? For driving several loads, only one motor was used, right? But in this case, what is done? For
Several
driving a
motors.
single load, several motors are being used. So can you just give me an example of such type of things? A very common example. Okay, let me show you. So can you track out what the things are? Are these the proper examples? This is robotic arm, right? This is a robotic dog, right? And what is this? This is a quadcopter. Have you seen all these things previously?
Sir, only in movies.
Only quad.
Yeah, but you
Only quadcopters.
obviously you have seen the quadcopters, right?
Only
And there
quadcopter.
are, yes, and there are many more applications within your own home also that do require all these type of things. Multi-motor type means for a single load you are employing multiple motors, right? So what are the basic components of an electric
But
drive
in
system?
robotic dog, sir, the
Yes.
different motor has different work, na, sir.
Yes. See, does it consist of a robotic arm also? It also consists of a robotic arm, na? And this robotic arm is also, see your own thing, your own hand. Your own hand is something like the same thing. It has different motor parts. It has different actuators in your own hand, which are used to take a glass of water also. So quadcopter, you see, quadcopter, how many motors are there for balancing?
4.
Yeah,
Must
four.
be must
So
be
for
four.
the single load, you employ 4 motors. So that is called a multi-motor drive system, right? Then you have the power source. So, okay, so what are the basic components of an electrical drive system?
Sir,
So basic components, first of all, you need power to run your motor, right?
Yes.
background is so noisy, sir.
Any problem? Okay, so first of all, you need a power source, right? For running your system.
Yes, sir. Yeah,
Then you need, right?
motor.
The power cannot be connected directly to the motor. What does it need? It needs a electronic controller. It needs an electronic controller, right? Yeah, are you able to hear me properly?
No, sir. The background is so noisy, sir.
But background noise is very high.
Some construction workers are being
Something
started.
happening.
Yeah. There's some construction workers are being started in the background. So just a minute, let me close the window. From the next class, I'll be taking it somewhere else. Okay, just a second. Okay, I don't know how much it helped out. So is there still very high amount of noise? Is there still very high amount
Yes.
of noise?
No, sir, it's somewhat less.
What was
It is somewhat
please,
less, sir.
just
Yes,
for
sir.
today
Yes, sir.
only.
It is
The next day I will find a better room with lesser noise. So first of all, we need a power source, right? Without which we cannot think of driving a motor also. So we need a power source and we need an electronic controller, right? So this is all open loop system. Means what? You are not seeing the speed of the motor. You are just supplying the power. Can you tell me an example of such a system? You know, the system is hanging just above you. Just find out.
Sir, can you repeat, sir?
First of all, I am pointing out to an open loop system. This is called an open loop system. Open loop system. Right. In an open loop system, you have a motor, obviously, you have a load, you have a power source, right? And in between, you have an electronic controller, right? Just like a electronic controller is there, you have a electronic controller, right? And by changing the, say, whatever the firing angle or the duty cycle, whatever you feel like, you are changing the speed of the motor, but you are not seeing the speed of the motor, right? Means the machine is not saying, the controller is not getting a feedback of the speed of the motor. So can you tell me such example of all this type of thing? Just give me an example of such a thing. It is just above you.
Fan.
Yes, perfect. So you have a fan, you have a fan controller also, right? So this fan controller is acting as an electronic controller, and the motor is here the single phase induction motor. So, and the power source is the grid. So that becomes an open loop system. But if you attach a kind of speed sensor here, speed sensor, you take in the input, then you have a feedback mechanism. Then you give this feedback directly to the controller. Then what you will get? You will have a closed loop system. Closed loop system. I think you have gone through the control system parts. Have you learned the control system in your
Yes.
earlier semesters?
Yes.
So there you have
Yes.
a
Yes.
open loop and a
Yes,
closed
sir.
loop system, right? So this is the closed loop system.
Yeah. Yeah.
In this closed loop system, you will be able to say you give a reference input of say 1500 rpm, right? Now what this system will do, it will try to keep the speed of the motor at exactly 1500 rpm irrespective of how much load you give on the motor. Obviously there is a maximum limit, but within that limit it will try to keep the speed of the motor constant. Is it important as far as that rolling mill was concerned, that I told that if you have two rollers and you are using it to roll two papers, then what will happen if the speed are not constant? So these are the two rollers, roller 1 and roller 2, and it is going like this. And then what you do is rolling at 1500 rpm. This is also rolling at 1500 rpm. Right. So what will happen if there is a difference in the speed due to the fluctuations in the voltages? What will happen? Say the voltage at some point of time was 440 volt AC. Now in the evening it has gone down to 415 volt AC. Right. Then what will happen? Then there will be a difference in the speed. Say one motor is having a very good amount of voltage, say around, say it is having a voltage of around say one motor is having 440 volt, another motor is having 415 volts. Then what will happen? Then the two motors will run at different speeds, right?
Yes, sir.
So if it is running at different speeds, there will be a wear and tear of the paper, right? So what do you need?
Yes.
You need a control system which will take in power in any voltages, say 440 volt, 415, 400 volt, but it will keep the speed of the motor constant. Don't you want this system?
Yes.
Right?
Yes, sir.
In that way, the paper will not tear up and it will be sold easily to the market, right? So what does a electrical drive system consist of? So it consists of a power source, as I told earlier. It consists of a power source. Power source can be of two types, but AC or DC, right? Converter, most probably AC, but there are some places where the DC is also there. Then it will consist of the converter, which will interface the motor with the power source, right? And it provides the motor with adjustable voltage, current, and or frequency. Say if it's a AC to DC system, which converter would you like to have? Say it's a AC signal, AC power, and you have a DC motor. So tell me, which power converter will you operate it with? Sinusoid.
Rectifier.
Yeah,
Rectifier.
which rectifier? If you just give an uncontrolled rectifier, it will start running at its maximum speed. Right. So which kind of rectifier?
Control AC DC.
Just a second, sir. Yeah. Sorry for the interruptions. Okay, so we would need a control rectifier, right?
Yes, sir.
Sir,
Yes.
sir, when you say interfaces the motor with the power source, what does that interface mean, sir?
Just think of about your fan controller.
Yes, sir.
Fan controller, what do you do it? It has a track, na?
Yes,
So
sir.
what does it do? It interfaces the AC line with the fan.
It's a between thing, right?
Yes, it's in between. That means you give the power input to the controller and take the power output from the controller and give it to the motor. So it is interfacing the motor and the power source.
Yes, sir.
Good.
Yes, sir.
Yeah. So if you have an AC source and you want to drive a DC motor, what do? And you also want to change the speed of the motor. So what do? You add a controlled rectifier, right? And with the control rectifier, you will just have the knob turning right and left. If you make this knob go this way or in the opposite direction, what will happen? What will happen? The speed of the motor will change, right?
Yes, sir.
So this control rectifier is acting as the interface between the DC motor and the AC power supply. Got. Now what is the controller? So what is the controller? The controller will actually, it is actually a microcontroller or microprocessor based. So it will actually control the speed of the motor or the torque of the motor, whatever it is. Then it will give the signals accordingly. Some algorithm has to be put into the controller. It will give the firing pulses to the electronic converter accordingly, and then the motor speed will be adjusted, right? And then it is the mechanical load, obviously, and finally it's the motor, the component part, which really will drive it. So in short, if you want to see it, it's something like this. So if you are using a crane, say, what you will have? You will have a power source. It can be any type of power source, not necessarily this one. It can be directly AC or DC power source, whatever it is. Then you will have the motor, right? And the power source, after the power source, actually this power electronic converter will come, which is right now inbuilt within this. And then it will pick up the loads. That load can be anything, mechanical load or crane type of load. It will depend upon which type of load it is.
Sir, that converter thing will be depending. Now, suppose we want to convert from AC to AC only,
Yes.
induction,
Yes.
then we do not need any converter.
Huh? Why don't you need any converter? Don't you need to change the speed of your fan? Is your fan running at full speed right now?
No.
Then how are you reducing the speed?
By use of that converter only.
Yes. So even it is from AC to AC, you are changing the voltage level also, no?
So then control can be done with the help of controller also. Why we need a converter? Controller.
How will you convert? How will you control?
Suppose
Automatically, how will you control automatically? Tell me. It's a simple case of a fan, right? It's a simple case of a fan. But think of a lift. Think of a lift. Let me draw a lift. If you have a lift like this, which is obviously there in a college, then tell me, how will you control if you're having this type of lift? How will you control?
By the use of controller.
So you will keep on adjusting your system unless you go up properly. Tell me. So sometimes in the lift, the speed will vary and the speed will change. Do you want such a lift?
Sir, we can automate it, right, by programming.
Yeah. So where will you program? Where will you program? You'll program in the controller. Your program will get dumped into the controller. Got it?
That's what I'm saying, sir. But why do we need a converter?
Converter to control the power. How will you change the speed? How will you change the speed?
Can be done by the controller, right? Controller
Controller will give signal to the power electronic converter. Okay, let me take a practical case. Just relax. I'm taking a practical case, and then we will discuss it after. Say, okay, so we will take a particular case, a very particular case. Like you have a, what is this?
Cycloconverter.
Cycloconverter. What is this? What? What is this?
Class C chopper.
Deep, you have forgotten everything. What is this? This is the
Frequency controller, I think.
नहीं हाँ,
This is a
full wave rectifier.
fully controlled rectifier, right? What is the
Yes, sir.
equation of this? Equation is V naught equals to 2 Vm by pi cos of alpha,
Yes, sir.
right? Now, where can you change this alpha? You will have a firing circuitry somewhere. You will have a firing circuitry. You will have
Yes,
a
sir.
firing circuit here. It will fire the 4 thyristors, right? So this one will be T1, T2, T3, T4. So it will accordingly fire the thyristors, right? Now
Yes.
you have to change the knob every time to change the alpha, right? Don't you think so? You have to change the knob.
Yes, sir.
Now tell me, you are, say, in the ground floor, you people are only 2 people, right? So only three people are there. You people are trying to go to the 5th floor, right? So it is ascending at a rate of, say, 0.5 meter per second, right? It is ascending slowly. Now in the 1st floor, 3 more people come in. So what will happen? What will happen?
Yeah,
It will
it's
become more slower.
Yes, sir.
Let's say it will go to, say, 0.1 meter per second, right? So in order to remain at that 0.5 meter per second speed, what you have to do now? This is case 2. In case 2, your speed has decreased to 0.1 meter per second. Now what you have to do?
So we have to increase that
What?
acceleration.
Definitely. But how will you do? How will you do? How will you do through this system? Say at alpha 1, it is 0.5 meter per second you are getting the speed. So now you have to change the value of alpha to alpha 2. You have to change the value of alpha, firing angle,
Yes, sir.
right?
Yes.
So in this case, alpha 2 will be greater than or less than alpha 1. Obviously, it cannot be equal to. So what
Yes.
will it be?
So it will be less than alpha 1.
Yes, if it is less, then you will achieve more speed, right?
Yes, sir.
Yes. So every time you will be changing this alpha by hand. So you will get a duty of liftman. Would you like to do that duty of a liftman every time? Liftman adjuster.
No.
No, sir.
You'll be sitting there 24/7,
Yes, sir.
trying to adjust the speed of the lift.
Yes, sir. That alpha controller part will be done by controller and by
Yes.
via sensor. Via sensor, we can
Yes.
sense the
Yes.
number of
So
people, and accordingly we can change the value of alpha 1 and alpha 2. From alpha 1 to alpha 2. So we do not need
yes.
any converter. Why are we
Correct.
using?
How will you control the speed? This is the polyphonic converter, na? What did you do? So here one controller will come. Here the controller will come, and here the speed will be seen by a speed sensor. It will give the speed input and the reference input. The reference is 0.5 meter per second. So you have commanded that under any condition, you have to maintain the speed of 0.5 meter per second. Whether 10 people are there in the lift or one person there is there in the lift, you have to have this 0.5 meter per second, right? Now,
The
where is the power
controller is
converter?
there, sir. I'm not telling anything about controller. I'm telling about converter. Converter.
What will you do? What do you want to do? Is the
Sir,
thyristor sets? You want to
suppose
cut
that
out the thyristor sets. This is the power electronic converter unit, no? This is the power circuit.
okay.
So you want to cut out this.
No. Okay,
Then
okay.
got it?
Acha.
Got
Yes,
the
sir, I
point?
got it. Yeah, now I got. I got it.
Actually, what this entire thing is called the power electronic controller. Sir. Starting, this is called the firing circuit, and this is called the power circuit,
Yes, sir.
right? So this entire thing is called the power converter side, and this is the controller. Controller is that microcontroller, Arduino, Raspberry, whatever it is. There are varieties of controllers available in the market. You have embedded systems on that. So this will actually control. So that's the basic unit. So did you
Yes, sir.
get the main essence? So it is
Yes, sir.
something like this. So this power source has this inbuilt power converter within it. So I did not draw it again. And then you have the motor and you have the mechanical load, which can be anything, lift, crane, fridge, any other thing. Then you have a sensor, which can be an optical sensor, which can be a Hall effect based sensor. Obviously it is detecting the speed also. Some people also detect the torque also. It is all dependent upon design to design. And then you have the finally the controller. This controller, whatever I used in my previous days, was the Arduino controller. Nowadays, VHDL based the programming languages are there, embedded systems are there, so they can use these things, and then you have the full control, right?
Yes, sir.
So, any more doubts on this?
No, sir.
So, just a second. So we have now mechanical loads, the types of mechanical loads, right? So what are the types of mechanical loads available? Can you tell me one such mechanical load which you face daily? Can you tell me one such mechanical load?
Sir, fan.
Yeah, anything more?
Water pump.
Anything more? Anything more? Good. Anything more?
So, mixer grinder.
Yeah.
Sir,
Anything more? Any other type of loads? Why? Your vehicle loads? E- Electric traction loads? What about that? Hello, am I audible?
Yes, sir. You are audible.
Yeah. So think of the traction loads. If you are driving an electric vehicle, then what is the load? Are you getting the point? That there are varieties of loads. Let me have varieties. You have a lift type of load. You might have a crane type of load. Right. So just a second, just a second. Yeah. So there can be a lift type of load, crane type of load, then electric vehicle type of load where the starting characteristics is something different, the running is something different. Then what are other types of load? pump type of load, fan type of load. So can you name some other types of loads? Okay, we will see it on the journey. There will be many types of loads, the meaning which each and every type of load is having a different type of characteristics. Do you get it? Say about a lift type of load and a crane type of load. What would be the difference? What would be the difference between a lift and a crane?
Power required will be more or less.
For crane, the power requirement is very, very high, but for a short amount of time only. Say for only 10 seconds, right? But for a lift, the power requirement will be somewhat medium, but it will keep on happening. It will keep on periodic, right? Then you have fridge type of load, a refrigerator type of load, which will keep on a constant load, but at regular intervals of time, right? So these are some type of load. In the later parts, we will see more types of loads. So let's go to the next one. Yeah. So electric drives, how you to select the components. So that's a challenging thing which you people are going to do as far as design component is concerned. Design engineering. If you want to get a job in this sector, you have to learn how to design an electric drive system. Right? Say there are many startups who are aiming on this electric vehicles, right? So they want a drive system for electric vehicles particularly. So if you are going there, then how will you design this electric vehicle part? So all these things, and now it's time that you clear the confusion and then move on. Then, okay, so there are steady state operation requirements. That means what? What should be the nature of the torque speed profile? Nature of torque speed profile means, what is the nature of an induction motor torque speed profile? Is it something not like this? If you learn properly, this is the torque speed profile of an induction motor. Then there is speed regulation. How much speed can you actually change? Can you change your speed of the motor from 0 to 60 in say 2-3 seconds? Is it possible? Then what is the speed range? How much speed can you maximum obtain? Can we obtain maximum from that motor? Can there be any speed range? Okay, what is the speed range of your fan of say a normal 4-pole 50 Hz induction motor? What is the maximum speed that you can achieve?
Up to 400 RPM.
No. What is the maximum speed of a 4-pole 50 Hz induction motor? So it is NS equals to 120 F by P. So what is it? 120 into 50 Hz by 4. So it accounts
1500,
to
sir.
1500 RPM, right? So your speed will be in the range only maximum up to 1500 RPM. So does your application need only 1500 RPM, or does it need much more or much lesser than that? It all depends upon the application, right? Then there are transient operation requirements. So say if you are using a weak induction motor, can you go from 0 to 60 km per hour in only 4 seconds? Can the motor give you that much of power? If it is possible, then quite okay. Else you have to see for other types of motors. Does that make sense? Does your motor allow very quick acceleration and very quick braking, like starting, braking, and reverse performing? So do you find any area where a motor needs to reverse also? You know, this lift does have to reverse, right? This lift operation, lift, you understand, lift, does it need to reverse? It needs to reverse now.
Yes, sir.
Yes, sir.
Go up and you also go down now. So what does it mean? The motor will have to sometimes rotate clockwise and sometimes it has to rotate anti-clockwise also, right? Same thing for the four-wheelers also. In the four-wheelers, what you go front also, you go back also at lower speeds, right? So there also reversing operation is required. And then the braking also has to be done. You know, a classic example of a 4-quadrant controlled drive is a lift. That lift with which you have been traveling up and down on this building, it is a classic example of a 4-quadrant operation of a motor. And we will see to it how interesting it is, right? So you will have starting, you have braking, you have reversing performance. Now power source requirements. So what are the types of power you need to have? So one is type, capacity, voltage magnitude, voltage fluctuations, power factor, harmonics, and its effect on loads. So it's a big list. Don't get frightened by this list. Right. Then you have capital and running costs. Say you want to have a refrigerator which has a 3-star rating, and someone tries to give you the same refrigerator but with 4-star rating. Which one you will want to go for?
6.
Huh? The second one, right?
So depends. Depends on what. How I'll be. If I'm going to use it 24 hours, I will be going with 6-star. If I'm going to use suppose 1 hour a
6-star
day, I
is
will.
not there. I think only 5-star is there. No? Means I will, if I give you two options.
Sir,
Option one
7-star
is,
is also there nowadays. 7-star has came.
oh,
Refrigerator
okay.
is 7-star.
So say for option one, uh, you have gone for 3-star, and for the second option you go for 5-star, right? So tell me which fridge will you try to take
Sir,
as far
on
as
the
running costs are
situation.
considered. No, you are going to operate it 24/7.
Then 5-star. Then 5-star.
Then 5-star, right? So 5-star means what? The running costs are less, right? And then the space and weight considerations are has to be taken in. Say if you are trying to make an electric vehicle and you have two options, you will have to have 5 HP of motor inside that, or say 2 HP of motor inside that, and you have two options to go for DC motor or you have to go for AC motor. Which one will you go?
So repeat the question, please.
You have joined a startup and your company wants you to give a 2 HP of motor to the electric vehicle, right? Now for 2 HP of power, which option will you go for, a DC motor or an AC motor?
AC motor.
AC motor, sir.
Why not DC motor?
Sir, AC motor we can control the speed.
So it has got advantages which DC motor hasn't got.
Exactly, which advantage are you talking of? That only everyone wants to know. Which advantage? See, first of all, for a specific power,
Sir, efficiency and
for a
reliability.
given power, yes, for a given power, the size of a DC motor is obviously greater than the size of a AC motor, right? So obviously for higher mileage, say if you are going for a bulky motor, what will happen? The mileage of the electric vehicle will decrease, right? But for the same power, if you go for a smaller motor, then the mileage of the motor will increase. The mileage of the vehicle will increase. So obviously you will go for AC motors, right? So are you getting it?
Sir, but
Yes.
if we take the
Puran, you are not audible. Puran, you are not audible.
if we take the DC motor, then we do not need to put a converter, because
Converter.
in
Okay, how will you change the speed then? You will connect directly the power source to the DC motor and you will run at full speed, fifth gear.
No,
Hmm?
sir.
You want to drive such a bike where you will just start and it will start running at the full speed.
No, sir.
Then how will you control the speed?
Using AC motor only, sir.
AC motor also will need a controller, right? It will also
Yes,
need a
sir.
controller. It will also need a converter. Can you tell me which converter does it need?
DC converter.
Oh no, no. The power source in electric vehicle is always DC,
DC
right?
to
And the motor is AC. So which converter you need?
DC
DC
to
to
AC.
AC converter. So what's that called?
Inverters.
Inverter.
Yes, and most
Inverter.
probably you will go for three-phase induction motor. So you'll need a three-phase power electronic inverter, right? And the control switch you will have connected to your accelerator part. And then it has to be seen as per the environment and location. Why is this thing important? Environment. Say if you're trying to employ an open type of motor in a underground region, underground mining region, what will happen? If there is any methane and if there is a little bit of spark, then a whole underground this thing mines will get blasted, right? And you have to see the temperature limit of the motor. If you want to apply it in some very hot areas like near the furnaces, inside some hot furnaces, then the motor has to have that temperature withstanding limit, and it might require to be completely sealed. Are you getting my point?
Yes, sir.
So as per the environment and the location, as per the environment and the location, you have to select such type of motors, right? And last of all is the efficiency and reliability. Would you rely on a DC motor more or an AC motor more?
Sir, AC motor. It's got better efficiency.
Sorry. And what about the DC motor as far as reliability is concerned? Reliability. See, AC motor is highly reliable only because of the fact that it does not have brushes. You know, the brushes of the DC motor can fail anytime. Even if you have a new motor, that brush can go down anytime, right? So DC motor is quite not so much reliable as is a AC motor, right? So most probably all the electric vehicle companies nowadays are going for AC motors only, right? Where there is no commutator. Means there may be other variants of AC motor, but they are all trying to go for non-commutator less motors. So finally, we have the difference between the DC or and AC drives, and then it's up to you to think during the application which type you want. So let me just complete it within 1 minute. I know you have a next class. So DC drives. Flip the pen. Okay. So as for the motor, the DC drives requires maintenance, is heavy and expensive, is limited speed due to mechanical construction of the brushes, and so the AC drives requires very less maintenance. It is light and cheaper. High speeds are achievable, and it is very much robust. Control unit, the control of DC drives is very simpler than that of AC drives, mind it. Then it has decoupled torque flux control. Then it has possible implementation using single analog circuit, means without the use of digital circuits also you can control the DC drives. But it is not the case in the case of AC drives. You cannot go for analog control for control of AC drives. You have to have DSP or fast processors. DSP is digital signal processing based processors, and it depends on very high complexity of maths. You have something called a vector control, of three phase induction motor. It is very highly complex, right? Highly complex, and all these complexities is being handled by DSP controllers. And then it has fast torque and flux control. So the control on the DC drives is very fast, whereas the scalar control is somewhat satisfactory, not very much, but the vector control makes the AC machines behave like DC machines. So it is very expensive and it is very complex, right? You will have to work a lot in order to install a single vector control. So this was the main difference. Now, as per the application, you have to think what you have to do, right? So I'll be stopping it here only. So see you in the next class. I think it's time up, na? 2 to 3.
Yes, sir.
Yes. So in any doubts, please,
Sir,
please
when
come
you
up
will
with your
share this
doubts.
PPTs?
Yes.
When we will be sharing this PPT?
Okay. Okay. I'll be. You have already the recording of the lectures, right? After 24 hours, you will get the lectures recorded. So PPT will be shared shortly, don't worry. But first of all, download the recordings after 24 hours, then you can again go through this. PPTs you will get. Okay, see you in the next class. Please post your doubts in the post section. Okay, see you in the next class. Your next class is on tomorrow 12 to 12:50. Okay.